All right, hi everybody. Welcome to another Educator Innovator Hangout on Air. I'm your host for this Hangout. My name is Trey Smith. I'm a teacher consultant with the Philadelphia Writing Project, and I'm also a Learning Sciences PhD student at Northwestern University in Illinois. Today we'll be sharing experiences and thoughts on the possibilities for integrating writing into science classrooms. Thank you for joining us here today, and a special thanks, a huge thanks to all our guests for making the time to be here. I'm really excited. For those of you who are watching this Hangout live, we encourage you to post thoughts, ideas, questions on Twitter, and you can use the hashtag connected learning, hashtag connected learning. So tweet us on Twitter, and at this point, we're gonna actually do a round of introductions just to find out who else is here. So give us your name, just a brief bio, and a little bit about what brings you to the conversation today.
Hey everybody, I'm Aida Awad. I'm a Einstein Distinguished Educator Fellow at the Department of Energy in the Office of Science. I'm also a Google Certified Trainer, and I'm going to be talking to you about some exciting ways that we have encouraged students to communicate through writing around 20% time. Talk to you in a few minutes.
And hi, I'm Linda Denstead. I am the co-director of the Oakland Writing Project, which is in Michigan, connected to the University of Michigan. And I am on the National Writing Project leadership team for the College Ready Writers Program. And that's exactly what brings me here today is I want to talk to you about a unit that's actually in the College Ready Writers Program and is being used by teachers and students across the United States.
Good evening, everyone. My name is June Tyson, 27-year career educator with middle schoolers on the northeast corner of Detroit. Currently, I work at NOAA, the National Oceanic and Atmospheric Administration, with education outreach and program specialist. And my draw to the writing that we're talking about tonight, early on in my career, I figured out that I just wasn't any good at teaching in silos. I couldn't just compartmentalize my teaching. I saw too many interconnections, and I saw kids light up when we could bring in all the other subjects together. So that's why I'm here. Looking forward to our conversation.
And hi, I'm Rebecca Vieira. I taught high school physics for 7 years in the great state of Illinois. And then I served as an Albert Einstein Distinguished Educator Fellow at NASA headquarters in Washington, D.C. And I am currently the K-12 program manager at the American Association of Physics Teachers. And I'm here tonight because Trey invited me, but I didn't really think about myself as being a writing teacher, to be completely honest. But when the last couple of years that I taught in Illinois, there was greater and greater emphasis on the ACT, and now that has a writing portion. And I mean, I've always valued the humanities as well, and I think that's something that students who often didn't necessarily like science were able to connect to in my class, and so I really grasped onto that. And so we did a lot of different things that were related to art and reading and writing, storybooks and writing children's stories in my classroom. And I just found that was a great way for students to express their understanding about physics when sometimes they couldn't grasp sometimes the more numerical things. And it helped them to go a little further than they normally would. So that's why I'm here.
All right, great. So I'm super excited. Let's go ahead and get started. And actually, I think I have on my screen right now a document that has a tiny URL link, and it's tinyurl.com/write-sci, SCI 2016. And if you're watching with us on the webinar right now, if you don't mind going to this link, and it's a collaborative Google Doc, it's open access as long as you don't have to sign in, you could be anonymous. And we'd actually love to hear from you, the participants, and I'll ask some folks who are on this webinar as well, who are guest speaking, if you could just find a space in this table row and maybe tell us a little bit about some of the writing that you do in your classroom. And specifically, you might talk to us a little bit about what types of things are students writing, who is the audience for some of this writing, why are the students writing, what's the purpose, when are they writing, and then where and how is the writing shared? And maybe that's in the classroom or maybe that's somewhere else. So if you could, take a second to jot down some quick ideas. And everyone can see this link. Is that true? Okay, great. I have some folks typing, so that's good news. And again, if you're watching us on air right now, you can go to tinyurl.com/writesci2016. And you just find a row and tell us a little bit about your classroom. And if you just joined us, we are on a tinyurl site, or a Google Doc, excuse me, and we access this via tinyurl. And so the address is here on the screen, tinyurl.com/writesci2016. And there are a couple of questions about our classrooms. We're going to hear from some folks about other classrooms, but we're interested in what are students writing, who may be the intended audience of some of this writing, why are the students writing, what's their purpose, when, and then where and how is this shared? All right, and I really appreciate adding to this, and this might be something that you can add to as you go. If you hear some ideas from the webinar today, this might be a space to go and jot down some of these ideas as well. So I say all this, and I want to make sure that I'm clear up front that our goal today is really to provide just a whole bunch of different options, almost a menu of options for thinking about writing in your classroom. And we're really interested in just the diversity of possibilities. And at some point in the middle of this webinar, we're going to take some time to try to make sense of these possibilities and maybe develop some framework for making sense of them. But right now, I want to turn the webinar over, if you will, to June. And June is going to share a little bit about how she's used some writing in her classroom.
One of the things I found out early on in my classroom of some struggling high needs learners is that we weren't sharing academic vocabulary too effectively. And so I sort of tried to back up the truck. I'm going to share with you here. I decided that I would use art as a way for my students to communicate with me. And so I came up with an idea called vocabulary cards. And it wasn't the traditional, what I had seen in the past. What I did instead was ask kids to start off by illustrating what they thought the concept was or what they thought the language was. And so if you can see here, the terms endoskeleton and exoskeleton. In this way, we could work together to develop academic vocabulary, and you can see right away that there are some issues with the word endoskeleton and exoskeleton. Exoskeleton in particular, it looked like students were having struggles with. So this was a great way for me to quickly assess and address some of their misconceptions. The front was the illustration, and on the back would be a definition and using it in a sentence. So again, what was great about this is that the students could have those ready when they came in on the day they were due, and I could flip through these and get a quick read and then pour into them a little later on and delve more deeply. But in this way, in a way that students were low risk perhaps, yes, but high impact. I found that it really helped my students understand what was going on and what we were talking about and accessing that important vocabulary.
Great, thank you so much, June. So the first example with June, thinking about scientific vocabulary and helping students access that, I want to transition us then to the next example from Rebecca, and have Rebecca talk to us about how she's supporting students' conceptual understanding of science with writing.
Great, awesome. First of all, let me just go ahead and make sure. Trey, are you able to see my presentation there?
Yes, we are.
Okay, fantastic. Okay, so this kind of looks a little scary. I probably realize the picture up here on the right. I'm currently working with some teachers who are learning how to use computers to help students understand physics. And the reason why I bring this up is because when we think about anything in science, we talk about students have these mental models in their mind. They think that the world behaves in a certain way. They tend to think about things in a particular way in their minds. And the way that we can find out how students are understanding the world, how they're making their predictions and their explanations, is to ask them to visualize it, to verbalize it. So there's lots of ways that this can be done. And if you can see on the picture that I've got here, I've got a little ball that's going to the right, a ball with an arrow going to the left. There's a whole bunch of variables, and this all, like I said, looks kind of scary. And so I found that having students write and verbalize is actually really good to help them understand, to demonstrate conceptual understanding, but also to help me see and to help their classmates see maybe where there's room for improvement. And the other thing I guess I want to mention is that by helping them incorporate writing, it helps them to demonstrate transfer. And that shows me that they actually understand what they're talking about. So I'll just give you a quick example here. One of the things we do in introductory physics, and this could be at even a very low level of physics. I mean, you could, this is basically, like I said, intro stuff. So we've got a graph here of position. Might not make a whole lot of sense the first time a kid sees it. But after you have them work through, have them do other different graphs, and then put words to it, it's very helpful for me as a teacher to see how students are doing. Now, this is not writing, this is not vocabulary, this is looking for patterns and representing patterns. And in physics, vocabulary, or the way that we use our words, is extremely important. Students will often say things like constant speed, or they might say constant velocity, or they may just use the word constant and actually mean things that are quite different. And you don't see those differences until you have kids use text and written language associated with the graphs or with the diagrams that we've got here in the lower right-hand corner, which show relative speed. And the way that I tried to bring this, to bring the actual strong, deeper level of writing into this, was I would have all of my students write stories that had to do with motion. So when students were learning about speed and velocity, I would have them think about a personal situation and to express that in words. And so I've got a particular student here who wrote a story about going out on the lake, which is something he would do with his father on a regular basis. And in that story, he would draw a graph that would represent that motion. But then perhaps more importantly, I would have the students actually tell a story that goes along with this. And so this is just one very small snapshot. So for example, here we reached the middle of Lake Geneva and a storm began. Since being in a sailboat is very dangerous in a lightning storm, we had to go into a port. We trimmed the sails and jibbed so that we would speed back to Fontana. Now, this student added some numbers and things like that, but that's not necessarily absolutely necessary. So these are just a couple other examples, and I'll leave you with this. I just think that in physics, people don't often think about writing. They think about equations, they think about numbers, they think about graphs, but you can take that and go much deeper. And the last bit here I'll leave you with is I would have my students take common misconceptions that students might have about forces, and I would have them explicitly write about them. We would do poetry, and then over here on the right, we've got an image of misconceptions about things that fall and which things fall faster on the moon versus on the earth, and why. And so that was kind of like a public service announcement. So just a variety of different things to kind of differentiate in my classroom. There you go.
Awesome. Thank you so much, Rebecca. And we'll come back to you in a minute, I think. So I wanted to just pause for a second and just say, like, so far we've talked about a couple different ways that writing is playing out in science classrooms, in 2 different science classrooms. And I definitely want to add, I taught in Philadelphia public schools for 7 years, and I want to add a little bit from my experience. And one of the first things that Rebecca was talking about is, trying to support students, or trying to get a sense of what mental models students are bringing to the classroom about phenomena. And then, taking time to work through some of that once students make it visible by writing it or drawing it or sketching it or even acting it out, right? Then also engaging in practices that, so students start to maybe change some of those conceptions, right? Change some of their ideas about in science. One of the frameworks that I have used and that has really been something that I think has caught on thanks to NSTA and some educators is this claim evidence reasoning tool. And so we put a bunch of resource links at the bottom of the webinar today. And one of them is this website from the Pennsylvania Earth Science Teachers Association. And there are some tools for helping support students' explanations, which is one of the things that we want students to be able to do in science, is to explain phenomena in the natural world. But they're going to base that on something that they have observed. They're going to base it on some evidence and some measurements. And this is the work that we really want students to start to be able to do as they develop their conceptions of different things that they notice and see in science. And so this is one of the resources that I wanted to share. On top of just understanding phenomena, we also want students to understand, so how do scientists actually do the work that they do? How do scientists communicate? And so a really common way that teachers do this work is maybe through science fair projects or through lab reports and through writing. And so I won't spend a ton of time talking about that, except that I've been really successful in the past using digital tools to help support students in writing these kinds of texts, if you will. And so for my students who were doing science fair projects, one of the things that we would do is I would create a template, and this template, each student would have an example that I shared with them. And then it's something that we also, the peers, the students could share with one another. And so they could give each other feedback on their writing. These templates had prompts and sentence stems to help students do some of the writing. In this case, this was for 7th and 8th grade students doing science fair. And so, some of the sentence stems are really, really helpful for the students, but also so were opportunities for the students to give each other feedback. Or let's say I wanted to share, I would ask a student if I could share an example of their work. I could go, because I had access to all these documents, I could print this out and distribute it in the classroom, and then the students could mark on this paper and provide feedback, and then we could talk about it, and then all that feedback could go to one student. And then we could do this in small groups once we've modeled it. And so this was one of the tools that I used to help support that writing. And in this case, this is a multi-week project where students are exploring individual projects. And so it's a lot to manage. And so this was a way to support that. Another digital tool with writing, in some cases, it isn't just about the longer parts, but there are some smaller parts. I'm sorry, this is kind of hard to see. Over here on the left-hand side, this is a Google form where I had students, when they were first proposing their project ideas, they would fill out a quick form to jot down the question that they had, some variables they're thinking about, maybe a hypothesis. And then that would wind up, the second graphic over to the right is the table where all of these different examples students submitted. I could go and print this out in the same class, right? When students submitted this via their mobile phones, or maybe we had Chromebooks, I could print this out in the classroom, and students could give each other feedback and make sense of all the different variables and all the different questions that their peers had. And so this was one way that I was, again, this wasn't, long writing. This was writing about, the scientific questions the students had. And again, this is a 7th grade example, and using digital tools to do that. I do have a link in the resources on the webinar page to a description of some of this work that I did using Google Docs and Google Tools with students. So I will share that with you, and please check it out. I do want to mention that one of the things about the next generation science standards, and I will talk just briefly about standards, because I do think this new version of the standards really emphasizes not just teaching isolated scientific skills, right, or habits of mind about using data, but it's really also about pairing that or combining that with the content, right? It can't be divorced. And so you have to be really careful about, not just trying to teach a scientific method over here this week, and then over here you're teaching about electricity. It's really about doing work where you can merge these practices, these habits of mind that scientists do, and in this case, we're talking about writing, a lot of communication with content. And so, Rebecca, I just want to turn it over to you now to talk a little bit about how you've been then trying to reinforce some of these practices, scientific practices with writing and data.
Awesome. Okay. All right, just to make sure, sorry to ask again, can you see my screen, Trey?
I keep muting myself. Yes, I can.
Okay, great. All right. So I've already shown quite a few examples of how you can take data that's graphical data, and how you can make some meaning out of that by, making it relevant, telling your stories and things like that. But when we talk about data, there's lots of different representations, and writing about it is probably the #1, from what I've seen, the most effective way for me to see if students are grasping it or if they're totally and completely lost. I think this is true also in computer science. A lot of times we tell kids to write pseudocode. So if you can't code something, well, then tell me what you'd want to code. And I think it's very, very true also with mathematics. So I just want to give an example here. I've got a whole bunch of raw data, and I've got some visualizations of that data. And I realize not everybody may be familiar with electric fields, but this is what we call a dipole, where you've got a positive charge on one end and a negative charge on the other. Students, and well, everybody frankly has a difficult time understanding electric fields. And so what I did to make that, help students make sense of this was 2 things. I think the writing can't be in isolation, just like Trey was saying here. It's really important that it happens together and that it happens with multiple other representations. So as an example, I would have students actually build a model electric field, but they would do it with clay. Electric fields we can think of kind of like hills and valleys. And so I had my students create hills and valleys. And then what they had to do was they had to describe what would happen. What is the story of an electron, for example, that we wanted to drag up these humps and down these valleys? What would that electron feel and why? And so having students, again, write those stories, and they can be very informal stories scribbled down on a piece of paper and told to a colleague, or shared with me or presented in front of the class. They're very powerful, and I think students found that they were very effective, again, for learning something that is conceptually difficult because it's not something that you can typically see or touch or feel directly. And so writing makes it a little bit more concrete with the addition of incorporating other things like actual physical models. Another thing I think that's important to mention is that when it comes to data, it's often contextualized in, it's contextualized in a story or in word problems is typically what we see. I would have my students take things like the example of this Barbie doll who happens to throw a pumpkin. It's what we call a projectile problem, meaning that we want to find out maybe how far away the pumpkin falls if we know how fast it was thrown out of the hands of Barbie. And I would have students create these physical models, but then in addition to that, they would write the problem, and then they would give me a full narrative of that problem. As you can see, it's quite a bit of writing. And thinking about kind of the style of writing that I would look for in this particular case for problem solving, I would tell my students to use stream of consciousness. And so you can see in this student's, here she writes, because this is a half projectile problem and we are only told the horizontal initial velocity and how far away the target person is, we need to solve the horizontal movement first. And so you can see she continues on and she goes into an incredible amount of detail. That it tells me so much more about students' thinking than just looking at their math work up above. So I really want to encourage people, as you tell students to show their work, have them think about showing their work through words in addition to showing it mathematically if that's something that you happen to do in class. This is just one final example here of students solving problems. I would have my students create problems. This one particular student create a problem where she used a spring pen and wanted to see how high it went and wanted to find out how much energy was in that spring. And as she did this, again, you can see we used on the left side solving the mathematical problems and on the right showing a narrative. Students, especially who struggle with the math, find that they could solve the math if they did the writing first. So that's one way that I think the mathematics can, that the writing can be particularly helpful at dealing with data. So there we go.
Awesome. Thanks so much, Rebecca.
Yep.
So, I mean, we could just, try to unpack all of those different ways that writing is playing out in Rebecca's classroom. And I think that's what makes any discussion about writing in science so incredibly exciting is because the possibilities, there are just so many of them, right? And so one of the things that we wanted to do in this webinar, though, was not just, we wanted to give you some examples, but we also wanted to give you some tools to make sense of these different examples. And so we were hoping to provide some frames so that you might start to say, okay, how am I using writing to maybe support this goal or that goal, and what are some different possibilities? So what I'm going to offer up for to you is not certainly anything that's fully formed or finished, but I did want to share just a couple of thoughts that I had about, why are some of the reasons why people might write in a science classroom. And also then think about why would we might write in general, and why might we write in science, and why might we write as citizens and human beings. And so those are important questions as well. But I did want to share with you, I wanted to go to a specific example here, which I think speaks on one level to some of the stuff Rebecca was talking about. But then Rebecca, if you think back to her examples, took what she was doing way beyond what the next generation science standards say, right? So this first example here is really about, as I mentioned, this idea about not just learning content, but learning the practices and habits of mind of scientists, right? So students are supposed to conduct an investigation, and in doing that, there's a lot of planning that goes on. You can imagine students are sharing their data that they're presenting on the conclusions that they came to, and they're really developing some kind of explanation of this phenomenon, right? And they're doing this by doing this other work that scientists might do. So if we compare that then, and I'm sorry this is, there's so much here, so much text. I know it's bad to do a slide with a ton of text, but I put the NGSS performance expectation in the middle about planning it and conducting an investigation to juxtapose it against some of these other ways that standards talk about writing. And again, I'm not presenting these as like the end all and be all, but I show them just to demonstrate that in some ways they're already pushing us to widen our vision beyond maybe just writing as a scientist might write into some other places. So for instance, if you compare to right to the left of it, there's this idea about synthesizing information from different sources that is in the Common Core, and really you're trying to maybe understand, it says to synthesize it into a coherent understanding of a process or phenomenon, right? And so this is very much related to the work that's happening, except the work that's happening with the next gen science standards. But in this case, you're really just doing maybe an experiment, but you may not be necessarily doing the work that a scientist might do. You might just be really just focused on conceptual understanding. And on to the left of that, you have another example from the Common Core, which I think speaks to some of the work that June was doing, which is about trying to just make sense of different terms and symbols and domain-specific vocabulary that students might need in science. But you can, if you look across these, we're really asking students to do sort of different things, right? It's not all, these are all examples where writing can play a part, but there are different types of writing and for different purposes. We compare that then off to the examples on the right-hand side, where, for instance, you're reading texts here and determining the central idea and the conclusion. That's different than planning an investigation. Now, you might do some reading of text to plan an investigation or to synthesize, to understand phenomenon, right? But these are slightly different goals, and we're supposed to be able to teach students to do all of these things. And then finally, on this far right side, which I think we're going to hear some more examples about, really integrating multiple sources of information from diverse formats to address some kind of question or solve a problem. And so what I'd like to be able to do is kind of move us into that space where we're thinking about maybe solving a problem. And I also wanted to offer up kind of just a simplified way of maybe making sense of all those different standards that were in NGSS and the Common Core, which is, and this is where we might ask ourselves, okay, so what are students really, what are we trying to get students to be able to do? Is it that we're trying to help them with academic vocabulary? Great, let's do that. Is it that we're trying to help them demonstrate that they understand some concept and they can explain a phenomenon, the theories and the descriptions behind that scientists have come to? Can they describe that using scientific language? Can they do the communication practices and argumentation practices that scientists do in scientific communities? That's I think another. It's related to these other two, the white box and the blue box, but this yellow box is asking them to do a little bit more. And then finally, are they drawing upon this knowledge they have in science, but really to participate in some discourse, some communities, some disciplines outside of science and engineering? And that's where I'd like to move our conversation. So I offer that as a framework, not because, like I said, it's not fully formed and it's not, the end all and be all. There are other ways to think about writing. But I just wanted to kind of raise the question of, what are some of the different possibilities that show up in the standards and that we see showing up in classrooms? And at this point, I'd like to start to push a lot beyond, not just a little, push a lot beyond science and into some other disciplines and spaces. And so I'm going to turn this over. And I think, June, you're up.
I really appreciate that framework that you have, because as I'm looking at it, it encapsulates so many of the approaches that I had with my students in my classroom. Like, for example, as part of a microbiology unit, I would work with my students not only to go around all across the school to swab different surfaces and see what might be growing, but also brought food safety into it as sort of a framework for them to understand. And what was great about that is then we could move forward with a diverse, from a diverse base to begin some writing. And so some of the things that I would do is offer them a menu of opportunities. And this wasn't just in this one unit, but just as an example, I would suggest to them, perhaps you want to educate others about what you've learned. And so maybe you would like to do a hand washing poster, and we'll put those up in the bathrooms, and also wherever they're in the sinks in the art room or things like that. So you would take your knowledge and formulate a way to persuade a change in behavior. Another opportunity that we discussed as a group, and sometimes we would come with these together, what about having some sort of a food safety procedure brochure that you could share with your little brother or sister? Because as they're learning to prepare food, you can let them know some of the key safety procedures that will eliminate or at least diminish the chance that they might get sick from the food that they're making. So each of these opportunities probably had a different approach, and also had a different mechanism for them to communicate. Also said to them, how about a comic strip? The bacteria are like being fought by superheroes. What's going on? And they would need to plot out what they would think would be occurring at the microbial level. Also, if they wanted to interview someone, perhaps the food service personnel in our school, or maybe it would be an expert from outside, or even if they just wanted to script out an imaginary interview, and then we could have them film it or act it out with the class. So I think what was great was being able to give them a menu to select from that they also were able to help create, that just like Rebecca had said, with doing the mathematical side and also writing it out. I think that for my students, we were able to, they need to know a certain amount to begin the writing, and then they also could continue learning and delving more deeply as they were doing whatever the writing was that they were creating for whatever audience and whatever purpose. So I just found that it enriched the learning for my kids to be able to do that.
Awesome. Thanks so much, June. And now we'll hear from Linda.
Yes, and so actually let's go back to Trey's lovely framework. I'm on the very far right. And so the work that I really want to talk to you about from the CRWP is engaging students and I'm inviting science students to think about writing really about social issues that are science-based. So Trey tells me that this is really called socio-science writing, which I love that phrase. And organizing evidence, and I put a link into, I think it's going to be at the very end of the webinar. You'll see it in the resources, to the unit called Organizing Evidence. This is a 1 mini unit that's in the College Ready Writers program that the National Writing Project has just been developed and engaging teachers and students in classrooms around the United States in the past 4 years. So what does organizing evidence do? Organizing evidence is just that, a mini unit. It's 1 week of instruction. It's really only 4 days. So it's just a bite into thinking about, if you're entering a conversation, a global conversation about space junk, in this case, in this unit, then how will you look at the evidence, and what are some ways that you might organize it to see it from different angles? Often argument is a binary, so it's what you should do or what you shouldn't do. But this is really inviting them into a conversation that for English students, often they haven't even heard of space junk. They don't even know that it exists, and they don't realize, unless they saw the movie Gravity in 2013, they really don't think that it's that much about that. A science student might actually have more background. So in an English classroom, students, they're learning scientific knowledge, dealing with a social issue. But in a science classroom, something different would happen. Really, students there are writing arguments, but they're going deeper into the science, and they're confronting real science issues that scientists across internationally are actually confronting and having conversations about. So let me talk to you just a little bit about CRWP. Give you a little background. CRWP in itself is a program that has a series of units that call teachers and students in all disciplines to engage in respectful, argumentative discourse. And I think Trey was actually suggesting that that's part of the science standards. So students are building routines in regular writing and thinking in terms of multiple ways of multiple views. And so the College Ready program really gets students in routine argument writing in 1 week mini units, and in extended work where students are doing their own research. And the whole goal is to create classroom conversations and then step into audiences beyond school, writing op-eds or blogs or any other kinds of conversations on digital sites, generally for students, sometimes print. And they can step into, especially digitally, into global conversations where students are even allowed. So why take argument in an argument mini unit like something that is also done in an English classroom into a science classroom? Well, first, and I want to go back to that last box, I think it's the science. I think it's a slightly different kind of science than labs and problem sets. It's the kind of science that is messy, that's authentic, that's problem-based, that exists in the world, and people are trying to solve it. And in a way, it's the same kind of argument writing that makes sense in a science classroom would be, maybe for the same reasons as an English or social studies classroom, is that that science students are actually going to grapple, just like English students, with complex science knowledge. The unit can be, there are texts in the unit that are more general, and then there are texts and videos that are very complex science. And so a teacher in different disciplinary classrooms could choose the text that they want students to engage with. I think the most exciting part is that we want to move students away from two views to multiple views and multiple solutions, because what students last year who piloted this unit found is that it's way too late to say you should not clean up space junk, which is a response in the late 70s, early 70s, late 60s. You know, just throw it out the window, right? That's how we got the problem. But it isn't enough any longer to say we should clean up space junk. And that's when they start realizing that there are historical beginnings and missteps and confusions that really drove major mistakes, that this is a complex science problem. And this is how the knowledge calls them to respectfully really engage with and inquire into lots of solutions. And when they do that, they come to a more informed and sophisticated response than simply should or shouldn't. And sometimes in this case, especially with space junk, the response that they have may not even be imagined yet. So they're dealing with what's currently been imagined. So I think the best part about space junk is that in the hands of science teachers, I think the conversation really gets into the depth of conceptual understanding of science solutions. It also offers a simple level of uptake of disciplinary scientific vocabulary, but it helps students see that misconceptions can actually lead to actually disasters in some ways, or possible trial and error solutions that don't work, and eventually to innovative and creative science solutions.
All right, thanks so much, Linda. And Aida, I think you're up next.
Okay, I'm just going to share my screen here real quickly. Oops, wrong one. That one's the one I want. All right. Is that coming through?
Looks great.
Okay, good. So I want to take you on a little bit of a whirlwind tour that is built around some opportunities to really develop student voice and to really give students opportunity for student agency. So this project is called a 20% time project, and just to give you a bit of a context so you can kind of understand all these different opportunities, I will say that 20% time projects are really just that. They are a commitment by a teacher or a course team to give students 1 day a week to work on a specific project of their own choosing, where students are really having opportunities to think creatively about some problem. Lots of times it's kind of a problem that has a local context, or some challenge that they see in their community. So students here are really deciding what they want to learn and what they want to work on. And I just love to show this quote from Jamie Cassup because it makes me think about the different ways that students can engage with different opportunities to communicate through writing and through other forms of media. And the reason that they want to do that is really that they're building those skills so that they can solve those problems down the road. So again, it's an opportunity to communicate, and when we talk to students about this at the beginning of the year, they're kind of aghast that, hey, I'm going to have a whole day in the week, every week, throughout the year to work on something that I'm really deeply interested in that has some scientific basis, and maybe it's a local problem, maybe it's a school problem or a community problem, but that people are interested, people like administrators or teachers or staff or parents or the community or some mentors. And so I'm going to just run through a whole bunch of slides that give you examples of ways we ask students to communicate. We start out with getting them to think about what the problem is that they really want to dig into deeply for that whole year. So we get their creative juices flowing by doing some things like a 30 circles project, or get them to think about writing down instructions. So this is kind of like the visualizations again. How do you build instructions? Is it visual? Is it a mind map of some sort? And then that takes them into what we call our bad idea factory. So we use a QFT, question formulation technique. You can look that up and grab these slides later on from the Right Question Institute, where students are in a specific set period of time generating lots and lots of ideas, some good, some really, really bad, and they're recording them, so they're writing them down. They're not talking about them, they're just getting them down on paper, and then later they're going to go back and refine those. So they're going to categorize them, they're going to prioritize them, they're going to find a way to share them out. So that way to share them out might be to put them into a Google spreadsheet here where they can share them with each other and work on categorizing and classifying them that way. From that, they're going to refine their ideas down to, or distill them down to, a specific problem statement. They're going to put that problem statement into a template that we provide them for the proposal that they're making. And they're making this proposal to their classmates about, hey, I'm going to spend a lot of time working on this. Here's my idea. Here's how I think it's going to go. And I really want feedback from you on it. So they do go through with a rubric, and they do provide feedback to each other. And of course, that feedback is written. And Google Docs, again, are great for doing that because they can add comments to each other on the doc right there. We encourage them to continue to communicate on a weekly basis. So it might be in the form of something like an infographic. It might be through doing some more background research. So they use Google Scholar a lot to dig deeper into the information that's there, developing those literacy skills, writing summaries for the research that they're doing if they're finding articles of interest that apply to their particular problem. And then we have them connect with a mentor or a group of mentors. And so we take them through a skill building workshop on writing a professional email. And we all know that they love to text, but boy, when you ask them to write an email, that's a bit of a challenge. So we do take them through that work, and again, writing in a different way. Here's an example of students who chose to write a blog and communicate that way. So they were just blogging on a weekly basis about what their work had been, what they had accomplished, what their challenges were as they were making their accomplishments, and what was next in their work. We also encourage them to learn about how they can make social media work for them as they're working through their 20% time project. So thinking about how you write differently in a social media setting and how you would use social media to further your cause on the project like this. About halfway through the year, they develop an elevator pitch, and that's just a 3-minute video. And of course, they have to write a script for that, and it's an opportunity for them to report out on what they've accomplished and where they're going with that and what the implications for the community might be. Again, there's a rubric that we're scoring the elevator pitch with and a rubric for the infographics. So where does this all end up? Well, we get to May, and it's time to do something in terms of a final presentation. So you can see on the right side a couple of my students with their professional poster session, and on the left side you can see a couple of students who are doing kind of a TED-style talk. But they're all required to do that formal presentation at the end. And these guys were pretty excited about wondering what other students might tackle in terms of a problem. So grab the links here, and here's some more links for you. And would love to hear from you guys with some more feedback. So I'm going to turn it back over. I think you've got it back now, Trey.
Yeah, thank you so much.
Awesome.
Wow,
Thanks.
We just went on a whirlwind tour.
Woo, I'm dizzy.
And just to be clear, we've moved from space to microbiology, right? In the past 50 minutes, we have talked about kids making movies to show physics concepts and dioramas, and we've talked about devoting an entire fifth of a class to problems that kids care about, right? And so this is just a really wide and just wide-ranging set of possibilities for writing, which is why I want to kind of return back to what I think is probably a really poor framework at this point based on your stories, right? Because the work that you're doing is stretching across disciplines, right? It's not just science in a lab, right? You're bringing in art, you're bringing in history, you're bringing in social studies and civics. and you're bringing in digital tools and technologies, and you're bringing in just so many different possibilities that enrich what you do. And so one of the things I just wanted to emphasize with the webinar is really for my own classroom, I would say, I would start to ask myself, well, am I supporting, that very those core ideas? The kids, are they developing that conceptual understanding? But then what are they doing with it, right? That seems to be the bigger question, and the question that you guys have responded to with each of your examples. And so I think that this tentative framework is, it's really kind of an expansion, a way to start to zoom out further and further and further and make some connections. I think we also want to return to sort of the question that we started with, which is something I would ask myself about my classroom, which is, okay, so what do we write in our classroom? And then who's it for? And why are we writing it? And when and where and how? And using these questions and thinking about audiences and purposes and genres and different media to really push myself and say, are students getting just a really diverse set of possibilities where they're learning science, but they're also learning, right? And they're learning how to learn. And they're learning all kinds of ways to connect what they're learning in the classroom to places outside of the classroom. And so I want to leave these questions up, and I want to turn to then and ask the group, and maybe we can have a conversation here about, once we start to open up these different possibilities and do the work that we do, or that you've described, what have you seen? How have you seen this opening up new entryways for students who maybe you saw initially weren't as engaged in science? And what has this done to really provide some new opportunities for students to access science from ways that, that they maybe not have done before? So any thoughts on just kind of allowing students to access science in new ways? Any reflections on that?
Well, I'll just start by saying that I think that science can be very intimidating for some students. Whether it's a parent sort of saying, oh, I was never good at science either, or maybe because we don't have as much science, if it's been crowded out by some of the testing that has been the gorilla in the room. But I think that by saying to students, hey, this is a whole new language. It's Latin. Of course it's hard. You're learning a new language. And being able to make it more fun and approachable with the art and with we're going to take these steps together. And also by giving them a menu to choose from and say, how do you want to communicate about this? It's not just, I'm going to write a report. So I think that seeing it from their eyes of how can I make it so it's not as intimidating and more welcoming, that writing has helped me do that.
So I'd like to speak really from the non-science classroom about an interest in science that emerged, because the teachers that actually did the space junk unit last year were English teachers, but this was the first science topic that the students had engaged with, and they were more interested in the evidence and more interested in the science than they were in some of the other social issues that the students dealt with, like food and nutrition, or raising wages. And so the science has, especially something like space junk, it has a draw and appeal, and students really pay attention to evidence and the science of it. So it makes a big difference for other students, not just science students. It's an entrance to science that they might not have before.
I'll go ahead and add a couple of comments about things that I've seen students really latch onto. So giving them voice and increasing student agency through opening up opportunities for students to do things that are really locally based and impactful is just a tremendous boost in their confidence and their ability to learn about science through solving problems, through having an impact, through doing things that they care about and that their peers care about. And when they're communicating with things they care about to their peers, they're very concerned about how their writing comes across and whether they're being understood. And those are the kinds of things, kinds of skills that we want them to have opportunities to practice and to provide each other with feedback on. So I think it's a great opportunity using all of the different tools and methodologies that kids like to engage in to help them have opportunities for practice.
And I'll add on to what Aida just said, and that's I think something that's really valuable is to have the kids communicate in multiple tiers. And so this is true for writing, but it's also true for speaking. And when you have different audiences and you're trying to communicate the same message to a peer, to an adult, like maybe a parent, to a fifth grader, and then to a preschooler. And like I think I wrote in the little document there, some of my students would make a strong connection between the stories that they would write and the kind of storybooks that they would create, and things that they were doing in teaching a preschool class. We had a preschool class that would come into our school twice a week, and then juniors and seniors in that preschool class would teach, the preschool kids. And I think they made a strong connection, not only to the science and to the little kids, but also to teaching. And it's really writing as a form of teaching other people, right? And there's nothing better for learning than teaching others.
Great, thank you. So I also was interested in, one of the big buzzwords you hear if you go to a science conference, a science education conference, is all about inquiry, right? The big I word. And but you also hear about inquiry if you're talking to someone who's doing history with historical primary sources, or someone who is doing some kind of project in the community. And so I'm wondering about, as we've looked at these different examples of writing, and maybe an example you've shared, but also one that someone else has shared or something that you're thinking of, what is that word inquiry? What does that mean all of a sudden in a science classroom when we've seen all of these different possible ways to write in a science classroom?
Okay, I'm jumping in. I was trying to find the mute button. I'm like, let me in, I want to talk. In my classroom with my students, what it has meant is it's given students an opportunity to take the science facts that we really want them to be able to apply, to use, and to make meaning and relevance out of those facts. So to apply them to things that they are passionate about, and to feel good about doing that. So I want to learn about this. I want to dig deeper. I see this phenomenon. I want to find out more about what happens if I do that, or what happens if this comes into play. So it causes them to ask more questions, which I think is what inquiry is all about.
So I would like to add on to that with just a small I inquiry, because what's happening in the 20% classrooms is a much bigger kind of inquiry. But just having students be willing to not go for the first answer or the information that fits with what they think, but to actually look for multiple views and multiple solutions. That smaller kind of inquiry is the beginning of respectful imagining and accepting of lots of even contradictory opinions. And so, and then they end up in the 20% classroom with a much more open mind.
Yeah.
I was just going to say that whenever I think about writing, I think about metacognition and students becoming aware of their own thinking. And it kind of, writing gives them an opportunity to concretize, make concrete, but also to scrutinize, to self-analyze, their self-talk in some sense when it comes to science and the way that they think about things, the way that they ask their questions.
And I just wanted to share, so in the graphic that was on the Educator Innovator website about this webinar, I had a picture from my classroom where we had extracted strawberry DNA, and we used a bunch of different, actually the physical properties to cells and the DNA itself to to separate this DNA from a strawberry. And I show this because I really have the question I'd ask is, in this case, we are not, we're not looking at the the actual atoms that make up DNA. We always have to model that, right? We can't see that here. So in this case, the experiment wasn't even about DNA as much as it was about physical properties and chemical properties. And so the writing that we did about that experiment was one type of writing. But maybe if I wanted kids to create a model of DNA and they did that as a play and they acted out something about DNA and maybe about transcription or something, then I've added on art, which is not and theater, which is not technically science, but I'm using that to help develop some conceptual understanding. But then we also might then do some op-ed writing about genetic engineering, right? And that's a totally different set of skills and types of inquiry, if you will. The different types of questions we have about DNA, I think are really rich. And so I share this as an example to say that if I'm looking at my own classroom, if I'm thinking about my own professional learning, right? Like, how do I maybe start with the lab, or maybe I start with an op-ed, or maybe I start with a modeling exercise, but what are all the different ways that questions about the world and about phenomena, but also about social issues, where am I doing different types and different versions of inquiry, I think is a question that I would ask myself. And I just wanted to use this picture of DNA as an example to illustrate what I think I've been trying to say this whole webinar is really just looking at all of these different possibilities. I did want to close this out because I think we're kind of at time at this point, and I just really am so thankful to have everyone on this webinar. What an awesome team. We have, just to be clear, we have National Board Certified teachers here. We have Albert Einstein Distinguished Educators here. We have Writing Project teachers here, members of different professional teacher organizations. And so just so exciting to have such a great group. If you look on the webinar website, you can find Twitter handles. You can find more information about each of us. And I just want to, if you want to go back at some point to the document, that's actually the first where we wrote about the different writing that you can do in your classroom. That link is there as well. So thank you all so very much. If you'd like to keep up to date on future Educator Innovator opportunities, sign up for the monthly newsletter at educatorinnovator.org. And you can also follow Educator Innovator on Twitter at innovates_ed. That's at innovates_ed. So thanks again, everybody, and have a great evening.